and welcome to another level 3 paper making video. Today we're talking about the chemical composition of dry fabrics. So, dry fabrics. You can have monofilament dry fabrics, which is just a single thread. You can have multifilament dry fabrics, which is a bit like cotton in a way, where you twist lots of threads together to make a single thicker fibre. And you can have some multifilament blends. In the drier section, we prefer to have monofilament fibres. Single filament fibres throw off the water more easily, and therefore the fabrics are what we call, they tend to run dry, they throw the water off. In the press section, we prefer multifilament fibres, but in the dry section, we prefer monofilament fibres. And this is a typical example of a monofilament fibre dry section. The materials that they're made out of, by far the most common material, is polyester. And in a moment I'll tell you just what polyester is and what the problem is, but probably 65-75% of all dry fabrics are made of polyester. Other things we make it out of is a material called Rhyton, which is a polyphenylene sulfide. If we look at multifilament blends, we have blends of acrylic fibres, we have blends that include Nomex. Nomex again is another aromatic chemical, and sometimes we even use fiberglass. Nomex is an aromatic polyamide. So the vast majority of dry fabrics are polyester. What is polyester? Poly means many, as in polymer, many molecules. Ester, an ester is a class of chemical compound that's formed when we react an organic acid with an alcohol. And probably the most common one of these is if we take ethyl alcohol and acetic acid, react that together, you get a particular ester called ethyl acetate. Ethyl acetate has a very characteristic smell of pear drops, and it's often used for the base of nail polish remover, that sort of stuff. So an ester is a reaction product of an alcohol and an acid. So for dry fabrics, they're esters, but they're not a simple ester like the nail polish material, they're a more complicated one. So the two monomers that we use, the acid is terephthalic acid and the alcohol is monoethylene glycol. So react these two things together, we get formed a polymer. So you can see terephthalic acid, monoethylene glycol, terephthalic acid, monoethylene glycol. So we've got this polymer, and these are what make the strands that we then use to produce the dry fabric. Now the problem with esters is that they suffer from hydrolysis. When these molecules are formed, when they polymerise, the terephthalic acid and the monoethylene glycol, a molecule of water is eliminated. So every time that chain is extended, a molecule of water is eliminated. When we talk about hydrolysis, this is another word that chemists use that means something that reacts with water. So because we're in the dry system, because we've got high temperatures and lots of steam, lots of water vapour around, the reaction tends to go backwards. So rather than the acid and the alcohol coming together and eliminating water, water now attacks that bond, puts itself back in place and splits up those two monomers back to their original material. So there we have the polymer. What we have now is what we call hydraulic bond cleavage. So hydraulic with water, bond cleavage is bond breaking. So the bonds between each of these monomers gets broken up, and we arrive with our individual molecules. We go back to terephthalic acid and monoethylene glycol. And the way that you would see this in the dry fabric is that it will become crumbly, almost like a biscuit. If you get a digestive biscuit and squeeze it tight, it will just crumble between your fingers. Well, the edges particularly of dry fabrics will do exactly the same because we have this hydrolysis, this reaction with the water. Typically this happens above 160 Fahrenheit, which is about 70 degrees C, and where the steam pressure in the drying cylinders is exceeding about 75 psi. So the temperature is, you've got the temperature there, you've got the humidity, and that will encourage the attack of these bonds with water, reverting it back to the individual monomers, and terephthalic acid is a very crumbly, powdery material. So a summary of dry fabrics and the composition of dry fabrics. 65% of all dry fabrics are typically made of polyester monofilament. Some multifilament dry fabrics are used in the hotter zone, so towards the dry end. So polyester towards the wet end, with a tendency to use multifilament fibres towards the dry zone, because there's not as much water there left to cast off, so you can get away with multifilament fibres. The type of blends that we use will involve Rhyton, Nomex and fiberglass. And final point, polyester suffers from hydrolysis. We get this hydraulic bond cleavage that will make the fabric brittle and biscuity. Okay, well, thank you for listening to this video, and please feel free to follow us on any of this social media. Thank you.